All right, now we're going to move on to cycle for day 2. Let's check that out. Okay, so cycle 4, day 2, simplify numeric and algebraic expressions with exponents. Okay, again, this is similar to what we saw in cycle 2, where we had to put things together and simplify using exponents. So method number 1, we are going to substitute x is equal to 3 and y is equal to -1 into the expression and then evaluate. Okay, so let's go ahead and do that. So we're going to copy it down, but wherever we see an x, we're going to put a 3 that's being multiplied. Same with the y, wherever we see a y, we're going to put a -1. And in this case, it is squared. So we have -1 squared, and here we just have an x that's being multiplied by the 5. So next, our next bracket, we see that there's just a 2. But beside it, we have an x. And what's x? X is 3. And again, it's going to be squared. And then we have a y that's right beside it. So those are being multiplied. This is being squared. Put on the denominator. What do we think is going on here? Looks like we have a 2 times 3 times -1. And then this is all squared. So everything on the bottom here will be all completely squared. All right. So let's take this step by step. We're going to do what's in this bracket, and then what's down here, and then finally multiply and divide. Okay, so we have 5 times 3, that's 15, and then 15 times, well, this is -1 squared, and -1 times -1 is +1, so here we just get 15. What about here? We see that we have a 3 squared, yeah, and 3 squared is 3 times 3, which is 9, so we're going to get 9 times 2, which gives us 18, and then 18 times -1, that's going to give us a -18. And then on the bottom here, we have 2 times 3, that's 6, times -1, that's going to give us -6, and then we have it squared, so -6 times -6, which is going to be a positive 36. All right, let's go put this into our Desmos calculator and calculate what we get for our final answer. So we have 15 times -18. Okay, so on top we'll have -270 divided by positive 36. So is our answer going to be positive or negative? Yeah, it's going to be negative. Because one's negative and one's positive. If the 270 is negative and the 36 is positive, so we'll get negative 7.5, or you can convert that to a negative 15 over 2. Right, great. So simplify the original expression using now exponent laws, then substitute the values and evaluate. Okay, so this is the other way of doing it, is to simplify using exponent laws. I'm just going to copy down the question again. So actually where most people make all the mistakes is copying it down wrong, but that looks good. All right, so using exponent laws, we're going to, well, when we have two bases that are the same being multiplied, we add exponents. When we have two bases that are the same and they're on top of each other for division, we subtract exponents. But here we're just going to calculate the top. So these are all being multiplied here. That means we can put together the coefficients. And 5 times 2, that gives us 10. We can put together how many x's we have here. And again, this is not adding, because we wouldn't be able to add an x and x squared. This is multiplying. Then when we multiply, this has a 1x, and this is x squared. That means we have 1 plus 2 gives us 3. Again, if we were adding, we wouldn't be able to put them together, but since we're multiplying the bases that are the same, we can add exponents when being multiplied. So the y squared and 1y here gives us 3y's. So that's the numerator. Let's check out the denominator. And this is just saying that we have two of these. Okay, we have 2 of these. There's 1 of them, and there's 2 of them. That's what it says. There's 2 of these from that squared. Okay, let's do this separately. So 2 times 2, okay, that's going to give us 4. We have 2 x's here and 2 y's here that are all being multiplied, so we can add the exponents. So 2 times 2, that's going to give us 4. So I took this and expanded it out, and I'm just solving it over here to put it over here. We see x times x. There's 2 x's, and if we were adding, we would get, if we had x plus x, we get 2x. We have x times x, we get x squared. So here, that's why we're getting an x squared. And then we have y times y, we're going to get y squared. All right, let's keep on going, and we can simplify. The 10 divided by 4 can simplify. They're both divisible by 2, so 5 over 2. The x's, since we have 3 x's on top and 2 x's on the bottom, these can subtract to give us 1x. And then we have 3 y's on top and 2 y's on the bottom. These can, 3 minus 2 gives us 1 y. And they both stay on, since they're not negative, they both just stay on the numerator. So you can write it like that, or you can write it like 5 over 2 xy. That's fine too. Next, we have to take these 2 numbers, 3 and -1, and sub them in for x and y. Okay, so 3 was our x value, and -1 was our y value. And well, let's solve this. We can put it into our Desmos calculator if we like, or we can just multiply it out in our head. So I'm going to type exactly what I see there. Again, -7.5 or -15 over 2. What do you notice between the 2 methods? We got the exact same answer. This is the same answer. We got the same answer. And you can pick and choose which one you like more. If you really like working with exponent laws, this might go a lot quicker. If you're not so great with exponent laws, but still can substitute and evaluate, great, you can use this method number 1. Doesn't matter which one you use, they both get the same answer. Right, you can push pause or rewind or fast forward if you like. We're going to move on to the next question. All right, so for this one, consider the expression. So we have an expression right here. Simplify the expression using exponent laws this time. Then substitute the given values, evaluate the expression. All right. So let's go ahead and try this one out. Okay, so I'm just going to rewrite the problem over here. Oh, I can see that the bottom is being squared. The 2m squared n is being squared. That means that there's going to be 2 of those. All right, let's figure out the numerator first, then put the denominator together. Okay, so our numerator, I don't see any squares on the outsides of the brackets, so that means nothing is being times twice. But it looks like these brackets can drop and this all be multiplied here. So we're going to multiply the -3 and the 4 together, and that's going to give us -12, because those are just big numbers. They can multiply together. What about these m's? This m and this m can come together to give us what? What do you think? Yeah, m to the 5. And then we have this n right here and this n. How many n's is that? Again, they're being multiplied, not added. Get 3. Right, along the bottom. Okay, I want to simplify this first. And first, I'm going to expand this out to give us 2m squared n times 2m squared n. Because there's 2 of them, I'm going to expand it out and give me one specific answer. So 2 times 2 here is 4. M squared times m squared gives me m to the 4, and n is n squared. All right, so 4m 4n squared, and that's going to be multiplied by 3mn. Okay, so we still have the -12m to the 5n cubed on top. But what's going on in the denominator? Well, it looks like these two can be multiplied together to give us 12 as well. And it looks like we have 4 m's and 1 m here. What's 4 and 1? Okay, that looks like it's going to give us m to the 5 here. And lastly, we have n squared and n. Yeah, that's also 3 n's. Right, and then for here, when we have the same base and they're being divided, we subtract exponents. So 3 minus 3, that gives us 0. So we're going to get no n's. These n's will actually reduce to give us 1. So no n's left. We actually get n to the 0, and n to the 0 is 1. What about m's? Well, this reduces and this reduces because 5 minus 5 is 0, and m to the power 0 is 1. All right, so really we're just left with negative 12 over 12. What's 12 divided by 12 is 1, so we're actually just left with negative 1. And then our last question, we're comparing. Are these two expressions the same? Justify your answer. Okay, so it's kind of like those games where you have to like see if you see any differences. All right, do I see any differences in the first term right here? Nope, those look the same. What about here? Hey, that looks different. What about here? That one looks different. That's not squared. And those. So are they the same? No, they are not the same. M is cubed in the second equation, or expression, sorry. An equation has an equal sign, an expression doesn't. In the second expression, and m is also squared. In the second expression. I'll grab some colors to just really emphasize that. So we see that m is cubed here and m is squared here. All right, so we can see that. You can also say that it's squared in the denominator or cubed in the numerator of the second expression to really emphasize it if you don't have any colors. Really, we're just looking for precision and accuracy, and that's all to deal with mathematics. Okay, and then we have some questions in the handout and the homework here. So here you're just putting 1 in for x and then solving. Here you're putting 1 in for x to get 2 to the power 1 is 2. And then you'll put 2 in for x again. You get 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4, and so on. And do you see any patterns? Can you predict some of the following? Predict the 1 digit in the following. So do you see any patterns happening? Can you evaluate here? Okay, so for this one, you're just inputting x. 2 in for x and solving. So wherever you see x, wherever you see x, you're going to put the 2. And likewise for all of these. And then they have the answers below. Let me know if you have any questions, and have a great snow day.